Fibrinolysis. So, what is fibrinolysis? Fibrinolysis is the natural body defense mechanism that enzymatically breaks down fibrin, the product of coagulation in blood clots to promote wound healing. Fibrinolysis is the final stage of blood coagulation. Its main enzyme is plasmin, an active fibrin protease that is produced from plasminogen. Plasminogen is activated to plasmin through intrinsic activators, factor 12A, kallikrein, HMWK. Extrinsic activators, tissue plasminogen activator, which is secreted by the endothelial cells, particularly tunica intima of the vascular system. It is considered as the primary plasminogen activator, a single-chain urokinase, which is secreted by the endothelial cells of the urinary tract, monocyte, and macrophage. It is considered as the primary plasminogen activator within the genitourinary tract. Contact phase activators. It involves factor 12A and its fragments kallikrein and factor 11A participation in the activation of plasminogen. Streptokinase, a product of B. streptococcus used to activate plasminogen to plasmin. Role of plasminogen and plasmin in normal and abnormal fibrinolysis. Under normal conditions, plasminogen is a part of any clot because of the tendency of fibrin to absorb plasminogen from the plasma. Plasmin is formed when plasminogen activators are used, which gradually dissolves the clot while leaving time for tissue repair. Free plasmin is also released in the plasma. However, antiplasmins immediately destroy any plasmin released from the clot. Under pathologic conditions, excessive free plasmin is released to the plasma. The available antiplasmin is depleted and plasmin begins destroying components other than fibrin. Plasmin acts more quickly to destroy fibrinogen because of fibrinogen's instability. The covalent bonds of fibrin slow the fibrin degradation process by plasmin. Four principal products of fibrinolysis, also called as fibrin degradation products or fibrin splits products. These degradation products are removed by reticuloendothelial system and other organs. The four principal products of fibrinolysis is fragments X, Y, D, E plus DD or D-dimer, an additional fragment. The early degradation products are the fragment X and Y, has anticoagulant effects. The late degradation products are fragment D and E. Primary fibrinolysis. It is caused by excessive plasminogen activators from malignant or damaged cells. Its effect is the conversion of plasminogen to plasmin even thrombin is not present. Primary fibrinolysis has an absence of fibrin monomer and polymer and D-dimer. An example of this is prostatic carcinoma. Second, fibrinolysis, caused by disseminated intravascular coagulation, uncontrolled and inappropriate fibrin formation within the blood vessel. It has the presence of fibrin polymer with D-dimer, most specific for DIC. An example of this is an infection of N. meningitidis, neoplasm, snake bites, and hemolytic transfusion reaction.